So in this video, I will go over what is called mesh analysis, or aka the smart way of doing circuits. So in most general physics E&M classes, they'll teach you how to do circuits, but they'll teach you a way that's very inefficient and confusing. So I guess I'll outline the general way that they teach you first. So the general way is that you define different currents. We'll call this like I1, we'll call this I2, and then we'll say that I3 is going down. And then you just start making loops everywhere until, because you have three variables, which are your currents, and then you need enough equations for all of your variables. So you need three equations. So the smart way, which is called mesh analysis, the way electrical engineers do it is we make as many loops as there are internal loops in the circuit. So in this case, there are two. So there's one internal loop here and another here. So we would define each loop as having a distinct current. These are sort of imaginary, but actually they have a physical meaning to them. So this I1 that I set on this left side is actually the current going on the outside of this first loop, and this I2 on the other side is going on the outside of this loop. So there'd be I2 going here as well, and I1 here. So what happens in the middle then? Well, we would define a direction that the current goes in. It doesn't matter which way. Whichever way that we define it will change the voltage drop direction across the resistor. So say we said that it was going downwards. From the circuit, we can tell that it's actually going downwards, but in the end, all our signs just take care of everything, so it actually doesn't matter. So if we say that it's going downwards, then what is this current? We'll call this big I. So what is this current? This current is actually I1 minus I2. So the reason why it's big I is I1 minus I2 is because we're assuming that the strength of I1 is, or the magnitude of I1 is greater than I2. So the net direction of the current would be going downwards. So the next thing we would do, let me just clean this up a little bit. So if we're saying that the net current goes downwards in the middle, we can label the voltage drop direction. It'd be positive on top and negative on the bottom. Remember that when we have a current going through a resistor like this, the voltage drop direction, there's always a voltage drop, so there would be less voltage on where the current is going. So in this case, it'd be positive on the top and negative on the bottom. So the next thing we would do is we would label all the other voltage drops. So let's do the left one. So if I1 is going upwards, then we would have a positive on the bottom and negative on the top. And likewise, on the right side, it'd be positive on the top and negative on the bottom because it's going downwards. Okay, let me clean this up. So after we've labeled our voltage drops, we can then write our equations for our loops. So the advantage of this method is if you do it right, you will always have enough equations for your variables. So you have two variables in this case, I1 and I2, and you have two equations. So let's do the first loop for the loop I1. So we can start, let's say, at the very bottom right here. So if we go clockwise, then we would hit our 1.5 ohm resistor first. So we'd be going into a positive. So remember, the signs of our KVL expressions depend exactly on whether we go into a positive or negative, whether there's a voltage drop or increase. So if we're going into a positive, it'd be negative 1.5 I1. And then we go hit the battery, we go into a negative, out of positive, so it'd be plus 12. And then go all the way around. So now we would hit our boundary resistor. So remember that we defined current to be going downwards, so we'd be going into a positive. So if we go into a positive, it'd be negative 1 ohm, so I just won't write that, times I1 minus I2. And then we've completed our loop, so we would just set this equal to 0. So then we could do our second loop. We can just start at the bottom again, go clockwise. I like to go clockwise every time just to keep it consistent. You can go counterclockwise, whatever. It doesn't matter as long as you're consistent with your method. So if we go clockwise, we go into a negative first. So then it'd be 1 times I1 minus I2. And then we go all the way around, hit the 12-volt battery. It'd be going into a positive and out a negative, so negative 12. And then into a positive, out a negative for the 1.5 ohm resistor, so it'd be 1.5 times I2. And then we complete our loop, so equals 0. So at this point we have 2 equations and 2 variables, and then we can just solve. So in another video I'll probably explain how to solve these quickly using matrices. You could just do it the old-fashioned way, is just substitute in one equation for the other, but that takes forever, especially if you get to 3 equations or above. So yeah, this is the mesh analysis method. If you don't believe me, this exists. You can Google it. So that's it.